number 3, find the reduced R of each of these block matrices. So let's start with matrix A. Well, it's obvious here that we have to make the first entry happen in row number 1, non-zero entry. So that means I would have to switch row 1 with the row 3, and I could do that. So I'm gonna put this row here and this row below. So then I would get 2, 4, 6, 0, 0, 3, and 0, 0, 0. Okay, clearly this needs to be a 1, so I would have to divide row 1 or multiply it by half. Multiply row 1 by half. So let's copy and paste here so we don't have to rewrite. So then this becomes why don't we just put it here? So this becomes row 1, so 1, 2, 3.
Same idea, but in that case, I got
okay.
the same procedure, I think. So it would be like the same pattern. So it would be 1, 2.
So now we have to divide row 1.
Then, oh wait, hold on.
Okay, we did. Okay, so now we could divide row. We could multiply 1/3 times row 2. Let me do it here. 1/3 times row 2. So so I can make that 3 a 1 there. So if I do that, then this becomes 0, 0, 1. Okay, and now I would want this guy here. So first I made this a 1 because it's the first entry in any column has to be a 1. The leftmost entry has to be a 1, so I made that a 1. Next I would want to make this guy here a 0, so that means I would multiply row 2 by -3 and add it to row number 1, and if I do that I will get let's see, -3, so this will stay a 1, this will be a 2, and the objective is to make this a 0, and it is. -3 plus 3 is 0. So now we are here. So this is my reduced form of the matrix, because the leftmost non-zero entry is a 1, and this would be the reduced form of the first question. So it's asking for the reduced R. Okay, so this does it for part A. Okay, now for B, B is just a block matrix AA, and so I'm just gonna align matrix A next to another matrix A. So let me copy and paste. So this is gonna be 1 here and 1 here, and notice that let's see, I would have to make, so oh, this is all zeros. Oh, okay, so this is already reduced. So this is the reduced form of B. So this is our B, this was our A. So that does it here. And let's take a look at part C, or matrix C. So matrix C is matrix A, block matrix, matrix A, and then 0. So this will be a bit big, so let's do it here. So that means I'm gonna get actually I still have A copied, so this is A, and next to it I have another A, and below it here I have another A, and here I will get zeros. 0 0 0 0 0 0 0. Oops, let me go up a little bit. 0 0 0. So this is matrix C. And now notice what I could do. I could subtract row 1 from row 4. Row 1 from row 4. So 4, row 4 minus row 1. Oh, sorry, the other way around. Yeah, no, that's correct. Minus row 1. So that would get me, let me, I'm gonna copy this whole thing so I don't have to rewrite it. And if I do that, I will get, I will change row 4. So if I change row 4, this is row 4, so I will get, let me put this in red, so 0. Notice the objective was to make this guy here a 0, so 0, 0, because we had a 2 there, 0, right, yeah, 0 0, minus 1, because it's minus 1, minus 2, minus 2, and then 0. Yeah. Okay, so now this is my matrix as of now. That's after I did row 4 minus row 1. And again, the reason I did this is because since this is my leading 0, everything below this column, below column number 1, has to be 0. So I had to make this one that's circled in red a 0, and I did. It became a 0 here. So now this is my new matrix. Now the next thing I need to do, notice that in column number 3 I have a 1 here. This is my first non-zero element in row number 2. So everything in that column, meaning column number 3, below that 1 has to be a 0, which means this guy needs to go to 0. So for this I have to do minus row 2 plus row 5. This is row 5, 1 2 3 4 5. So I can make this one here, the one next to the arrow, a 0. And if I do that, let me copy and paste this so I don't have to repeat it. So I'm going to change row number 5 because my operation is taking place on row number 5. Okay, so minus row 2. So minus row 2 plus row number 5. So 0, 0, because that's just 0. 1 second. Minus row 2, yeah, 0 0. Now minus 1 plus 1 will give me a 0. 0, originally I had a 0 here, so this will just be 0. and here I have 0 0, and this will be -1 because -1 times 1 is -1 plus 0 is -1. Okay, so now this, everything here is zeros, everything here is zeros. Let's see. Yeah. Okay, now this guy, needs to be a 0 because under this 0 I have to have zeros. So now let me change the color here. So let's use pink. Let me take this away. So I need this to be a 0. So what I'm gonna do is I'm gonna add row 1 plus row 4. Row 1 plus row 4. So that will make this guy a 0 because 1 minus 1 will get me a 0. And I might as well in the same step do the other one. Actually, it's okay. Let me do it steps so we could see it better. So now let me copy and paste this. So I'm gonna change row number 4. So now row number 4 will become, so let me erase row number 4. So I'm adding row 1 to row 4. So I'm gonna get one, just 1 second. Row 1 and row 4. Sorry, the screen just froze on me for a second. Let me just fix it really quick. Okay, screen is back. So row 1 to row 4. Sorry, this has to take place. Now think about it. If I work on this row here, I'm gonna mess up the 0 because then this 0 will become. Oops, again froze. Oh, one moment. Oh, the whole thing froze. Okay, so I was saying before my screen froze that so here I have 2 ones. I have this one and I have this one, and one of them has to go away because this is if this was the first non-zero in row number 4, everything above it and below it has to go to 0, which means I need to get rid of this guy here. And the way I would do this operation, but instead of row number 4 I would do it on row number 1, so that would take care of this one here, which becomes a 0, which I need it to be in that 4th column. Okay, so and if I do that, I will get so this row will stay the same, 0 0 0 minus 1 minus 2 0. So this is the original matrix up there, which I had copied and pasted. But now I'm gonna erase the row number 1, and after I add row number 1 to row number 4, I will get 1 2 0. 1 minus 1 will make this a 0. This is exactly what I'm after. and then 2 minus 2 is also a 0, so that killed that guy too, and 0 and 0 is 0. Okay, fair enough. So far this is my block matrix. Now I need this guy here to go to 0, because this is let's see, yeah, because this is the first -1 is the first non-zero in there, so everything above it and below it has to be 0. So if I do that, I will get, so my objective now, let me change colors here, I need to kill this guy here, and for that I could do row 2 plus row 5, because -1 plus 1 will kill that 1 up there where I put the X on. So and it won't affect any of my other entries, because everything in row number 5 is 0 except that -1, which I can use effectively. So let me copy and paste this, if this pad cooperates. Okay, so we said row 2 plus row 5, row 2 plus row 5, and this is taking place on row number 2, so let's erase this. So we'll get 0 0 0 0 and -1. We had 1 here originally, if you remember, so this will make it 0 and wait, no, 0, sorry, 0 0 1 and then 0 0 0. This became the 0. This is the one I was after. Okay, and now let's multiply row number 4. I need this to be a +1, not a -1, so I can multiply row number 4 by -1, and likewise I could also do row number 5 by -1, because I need this to be +1. So then I could do those in in one step, because they don't depend on each other, so I don't have to redo 2 different steps. Okay, so let me copy and paste that. Okay, so I'm multiplying row 4 and row 5 by -1, so I'm just gonna switch the sign on row 4 and 5. So this will become a +1, this will become a +2, and this will become a +1. Everything else zeros, so it doesn't matter. Okay, let's check. Does this qualify to be my reduced form? Yes, because it conforms to the criteria. It conforms to the criteria of a reduced row echelon form. The criteria again is if there's a row where every entry is 0, then this row lies below any other row that contains a 0 entry. Well, I mean, I could switch, it's not a big deal. I could switch this row and put it under, so that's not a big deal. The other criteria is the leftmost non-zero entry of a row is equal to 1. So this here is 1, the leftmost. This is 1. This is 1, and this is 1. Yeah, so I'm satisfying that. And then the leftmost non-zero entry of a row is the only 0 in that column. So notice that under this 1, everything here is zeros. Same here, right? Yeah, it's the only 0 in the column, so the zeros, zeros, above and below, zeros. Well, this doesn't matter because I already have my one. This is my one here, so zeros below. Okay, so yeah, this is my final answer. This is my R. This is my RC. So this is my matrix, my reduced form. This is the reduced form of the matrix, which is, if you notice, what was A here? A was 1 2 0 0 0 1 0 0 0 1 2 0 0 0 1 0 0 0. Notice, actually, it's an interesting result because in the final answer, this, oops, let me do it in a more suggestive color. This is A, yeah. This is a zero matrix here, so I can write it in blocks. And this here is a zero matrix, and this is A. So in effect, when I reduced, what was it? C, A 0, I was able to get RA. So RC is, the block matrix is RA 0 0 RA. That does it for this question.